Fellows out there, welcome to lecture 8 of module 1 in my video series Introduction to Data Structures in C. Today we will go through some code snippets and get to know some of the concepts that we have studied in my previous lecture. Okay, just go through this code, type it around, do a dry run, compare your predicted output with the actual output that you get. Okay, so pause this video, have your try, and then come back. Let's look at the answer later on. Okay fellows, so the question here is, here I have a code snippet. Okay, so I have my main function out there, and given out here is a string array, a character array which is a string. Okay, which has been initialized to the string Canada College. Out in this part of the code, what is being asked is, what is that you can fill in out here so that you can print just the college part out from this character array or the string. Okay, so you need to write something out there apart from say the word college. Okay, I just need to get this part out from the string and print it off. So that's the problem out there. Okay, hope you have got the answer, and let's look at the actual output. Those who have written something like that, bravo. Okay, so the answer out here is, here this question mark needs to be replaced by this, that is array plus 7. What this actually does is, the array gives me the base address of this character array or this string. Okay, and this plus 7 basically increments this pointer by 7 data types. Okay, here it is a character pointer, so this is the first, second, third, so it goes up to first, second, third, fourth, fifth, sixth and seventh. Okay, so here it is where your thing ends there, and basically I take this array, offset it by a value of 7 and print everything in the string from there on. Okay, which is nothing but college. So that is what happens out here. So I get the base address, increment it by 7, okay, and then print everything in the character array or the string from there on. So that's the output, that's the answer that was expected. Okay fellas, let's look at this other piece of code. Guess the output for this. Do a dry run, type it around, compare the output. Let's come back and look at the answer later on. Pause this video, do these activities. Okay, fine. Okay, hope you have got the results, and those who have got it as 4, bravo. Some people, depending on the compiler, might actually get it as 8. Okay, so because we know that the compiler allocates the memory depending on the compiler or the target that you have set for. Okay, so let's look at this piece of code. So in the main function hash if not defined null, I define null as 5 and then end this. So this is a macro which has been defined inside the main function. Okay, so this is the macro which has been defined inside the main function. What does the macro do? It basically takes a null pointer and then points it to something else. Okay, so then I have a print function which prints %d null plus size of null. Okay, so the output that you expected would have been, say, 5 plus 4 might be 9. Okay, but that's not how it works. What actually happens out here is, even though I am basically trying to point the null pointer towards something else, C compiler doesn't allow it. So we cannot copy anything into a null pointer. Okay, we cannot copy anything into a null pointer. Oh god. Okay, so that's what happens out there. Okay, so size of null null plus size of null. Null, as we know, is 0. Size of null is the number of this basically is taken as a data type. So size of the null, so size required to store the null, okay, which is 4 in my compiler. So what you get output might be 4. If you are getting it as 8, do not worry, just print out what is the size of null, and probably your compiler might have allocated 8 bytes to store this null pointer. Okay, basically if you are working on a 64-bit machine. Okay, let's look at the other piece of code. Okay, this is pretty interesting. Okay, in the global definition part, what has been defined out here is a macro which says that hash define scanf as this string value, that is percentage s Ganesh V Bhatt, and then in my main code what I have is scanf and scanf. So as we know from the definition of macro, what do you expect? Okay, so do a diagram, type the code out, compare the output. Let's come back and look at the answer. Okay folks, if you have got something like that, well done. Okay, so basically looking at the preprocessor directives or the global definition part in the definition section, what the macro does is basically it replaces both the scanf with percentage s Ganesh V Bhatt. So basically it gets something, you should interpret what happens under the hood as something like that. Okay, so what does the first piece of code do? It basically percentage s, so it's looking for a string to be printed out instead of percentage s. So what goes out there is percentage s Ganesh V Bhatt, and that's what gets printed out. Percentage s Ganesh V Bhatt, that's what gets printed out. And from there on, having completed this part, what remains is Ganesh V Bhatt, and then we get that as well as the output. So that's what happens in this piece of code. Okay, so that pretty much summarizes how a macro works and how do you interpret a macro in your main code. Fine, let's look at another piece of code. Okay, so just guess the output, determine what the result is, compare it with the results that you have guessed. Let's come back and analyze what has happened under the hood. Okay guys, so what happens here is you might have got this as the output. So let's analyze what happens in this piece of code. So basically what it does is very similar to what we had seen in one of my previous codes. So this 5 gets basically acts as a preset for this particular string or character array. So the printf command basically offsets itself from the base address by a value 5 and then prints the rest of the characters in the string. So 1 to 1, 2, 3, 4 and 5. So this pointer which was initially pointing to this part now points to this and starts printing from there on. Okay, so that's what happens when you execute this piece of code. So instead of printing math quiz, it basically just prints quiz out. Okay, fine. Okay, so what happens out here? Guess the output, get the results. Let's come back to the code. Pause the video, do these activities, and then let's analyze this piece of code. Again, the difference between the last code and this code is that instead of percentage s, now I have percentage c. So I will be basically printing just one character out. And very similar to the last piece of code, the initial address is now offset by a value 5. So this gets offset right there and printf starts printing everything from here on. How many characters does it print out? just one character. So the output that you get is just Q instead of quiz. Similar results can be obtained by just modifying it like that. Okay, so these are different ways in which you can offset the starting address from which the printf starts printing the character array. Okay, the same results are also got by this piece of code as well. Okay, go through these 4 statements and tell me which of them is true. First one, gets can read a string with a new line character but a normal scanf with %s cannot. The second, getS can read a string with spaces but a normal scanf with a %s cannot. The next one is getS can always replace scanf without any additional code. And the last one is none of the above. So the answer to this is B. If you have guessed B, then yes, you are right. Okay, scanf getS can basically read a string with spaces but a normal scanf cannot, with the %s cannot. Okay, so that's the advantage that you get when you use getS instead of a scanf, okay, which is a formatted input which has been formatted to reading string, that is using %s. Okay, so again guess which of the following 4 statements is true. getS doesn't do any array bound testing and should not be used. fgetS should be used in place of getS only for file, otherwise getS is fine. getS cannot read string with spaces. None of the above. And if you have guessed A, yes, you are right. Okay, because let us look at this piece of code. What is happening out here? Here I have a characters array or a string of 20 characters. So 20 memory spaces have been allotted for the character array named str. Next I use the getS command to read the string from the keyboard into the character array, and then I print it out. When you execute this piece of code, suppose if you have printed or if you input more than 20 characters from the keyboard, there is no error message or a warning given to you, whereas this particular printf, the scanf basically reads everything from that. Okay, and then when you use a printf, you have a problem of the buffer overflow. But if you replace this getS with fgetS, we have a constraint on how many characters to be read from the input. Okay, so the size of string is 20. So at the maximum you can read 20 characters into the string from the keyboard. Anything over and above this 20 characters will be directly truncated and you do not have a buffer overflow condition. So it's highly recommended that you use fgetS instead of getS wherever possible. Okay, so that's the takeaway from this piece of code. Okay, the same thing has been explained out here, saying that why getFS is better than FS. Okay, let's go to the next one. Okay, that's all for folks today. Hope you have enjoyed this lecture. Stay with me for another round of Guess the Output in the coming video. Thank you.